The topic is called sulfur and its compounds, meaning we are going to be looking at compounds of sulfur. What do we know about sulfur? Sulfur is, if we take its atomic number is 16, and meaning that it has 16 protons and 16 electrons. So its electronic configuration is 2 to 8 to 6. What do we get from this electronic configuration? It tells us that sulfur has 6 electrons in the outermost shell. So sulfur belongs to group 6 of the periodic table, as you can see. Group 6 because it has 6 electrons in the outermost shell, and it belongs to period 3. Period 3, that means that it has got 3 energy levels or 3 shells. Now, how does sulfur occur? Sulfur occurs in two states. It can occur as a free state. It can occur as a free state, or it can occur in other compounds of sulfur. In free state, sulfur occurs underground. It is like these minerals which are extracted from ores, which we find underground. So in a free state, sulfur occurs underground, and we are saying it is usually 160 to 200 meters below the ground level. If we have a deposit of sulfur or a place where sulfur is, it is always found 200 meters below the ground level. And think about 200 meters. You remember the pitch when we used it to run 100 meters. So 100 meters times 2. So that is the level where we find sulfur below the ground. So that is where sulfur occurs in free state. Now it also occurs, it can occur in other compounds when it is combined with other compounds. For example, in sulfates, take an example of copper 2 sulfate. In that formula, you realize that there is a symbol of sulfur. So sulfur can occur in such compounds. It can occur in sulfides, for example, hydrogen sulfide or iron 2 sulfide. Sulfur can occur there. Then it can also occur in sulfides. So it can occur in sulfides, in compounds, it can occur in sulfides, it can occur in sulfides, and it can also occur in sulfates. It can also occur in crude oil. So what do we note from this part? If you have the notes and your pen, you can go on underlining the important points. So occurrence of sulfur, we are saying it can occur in free state, free as a free element, or naturally by nature. And where do we find it? It is found underground. How long underground? We are saying about 200 meters below the ground. That is how it occurs naturally, or in free state. And it can also occur in compounds. For example, compounds which are sulfates, like iron 2 sulfate. In that formula, you realize that there is sulfur as an element, so it occurs there. Sulfites, a sulfite ion or radical is SO3 with 2 minus. So sulfur is still there, and it can also occur in sulfides, like hydrogen sulfide. Hydrogen sulfide is a compound of hydrogen and sulfur. Extraction of sulfur. Now, This is where our real chemistry on sulfur starts. Extraction of sulfur, we mean that sulfur that is underground. How can we get it out from there? That is the question. Extraction of sulfur from underground. We are stressing, or we are emphasizing that sulfur is found 200 meters below the ground. Eh? This makes mining it impossible. You can imagine digging 200 meters down the ground. Eh? It is somehow impossible. Eh? So what do? We use other methods. Now, the method which we used to extract sulfur was invented, or it was discovered by a man called Flash. This is the name, Flash. So this is the man who discovered the most appropriate method of extracting sulfur. So because he is the one who discovered the process of extracting sulfur from underground is called the Flash process. So we may ask you, name the process by which sulfur is extracted from underground. And I'm saying the process is called the Flash process. Flash process, not the spelling. Don't forget this S or anything. So sulfur is extracted from underground by the process called Flash process. Now, what is involved in this Flash process? We dig, or we come with three concentric pipes or three long pipes. Yes, because so here we are saying sulfur is extracted from underground deposits by this method, basing on its low melting point. So sulfur easily melts. It has a low melting point. So how can we make it melt? I'm telling you that we dig, or we put underground three concentric pipes, or three pipes. Now, I want us to study this diagram very well. These are the three pipes. Now, this one that you are seeing, where my arrow is, this one here, is the outermost pipe. And the outermost pipe, those who do art, is the one that continues. Even this one going down, it is still the outermost pipe, or the largest pipe that is outside. The outermost pipe, the very outermost pipe, is this one. So what do? If we want to melt sulfur, we add through that outermost pipe. Take note of that. In the outermost pipe, we put in superheated water at a temperature of 170 degrees centigrade. Now, you imagine if water boils at 100 degrees centigrade and it is very hot. But we are saying this water which we use to extract sulfur, to melt the sulfur underground, that we add through the outermost pipe, that water should be 170 degrees centigrade, and there should be pressure also. So the superheated water is let in the sulfur bed. You see, this is the ground level, sand and clay. So as you dig down, you are going to reach where there is sand and clay. Then you continue going down until you reach the sulfur bed. So there's someone who is asking something. Let me first tend to this person. Could be important. Anyway, I will find it. So this is the outermost pipe. I told you that we use three concentric pipes. So after the outermost pipe, there is the innermost pipe. The innermost pipe. We have three pipes, but we have one which is the outermost. Then we have the middle pipe, and then we have the innermost pipe. the one which is inside the innermost pipe. Now, in the innermost pipe, we add hot compressed air, very hot air, hot compressed air. Why is everything we are adding in hot? Sulfur is naturally a solid, so we want to melt it. We are saying we use this method basing on the low melting point. So we want to melt our sulfur. We want to melt our sulfur. We want to melt our sulfur, so we use hot compressed air and superheated water. Now, when the hot compressed air goes to the sulfur bed and the superheated water, now the sulfur will be forced to come out of the sulfur bed, but now it comes out in the middle pipe. This is the middle pipe. I told you this is the outermost pipe and it continues. It is this one where you see arrows going down. So this one here, go with my pointer, and this one here is the outermost pipe. Then this one is the innermost pipe I told you, where we put hot compressed air. Then this one now becomes the middle pipe, where you see arrows coming up, and now the sulfur comes out in the middle pipe. So take note of that. What is important here? In the flash process, we are saying we drill flash pump consisting of 3 concentric pipes. Underline this if you have your notes there. 3 concentric pipes down the sulfur deposit. Now, superheated water or steam, about 170 degrees centigrade, is forced down the outermost tube. Please, this is what we mark. Our marking points, number 1 are you drill 3 concentric pipes. So this is a marking point, 3 concentric pipes. Now, note superheated water must be forced in using the outermost pipe. You are going to draw this diagram later. So the superheated water goes in through the outermost pipe. Then what else goes in? Hot compressed air is pumped down. But for hot compressed air, it goes in the innermost tube, or in the innermost pipe. And what happens after that? The melted sulfur, because we do all that to melt the sulfur, the molten sulfur or the melted sulfur will be forced to come up, but it comes up through the middle pipe. Just for the sake of those who have just joined us, I'm repeating. I'm saying superheated water at a temperature of 170 degrees centigrade is let in the outermost pipe. Then after that, the hot compressed air is let in, or is forced in the sulfur bed down, is pumped in the sulfur bed, but using the innermost pipe, and sulfur, the melted sulfur, comes out through the middle pipe. So this is the middle pipe. This one, this one is the middle pipe. It goes like this, like that. So that's where the melted sulfur comes out from. And when the molten sulfur comes out, it is going to be collected and processed. It comes out as a liquid. So you continue and say, through the middle tube to the surface where sulfur is cooled. It comes out as a liquid when it is very hot. So you cool it and solidify it. The sulfur obtained is 99.5% pure, and it can be used directly. So this is where the extraction stops. I repeat, the most important points in extraction: 3 concentric pipes are drilled, hot compressed air is let in the innermost tube, then superheated water is let in the outermost, the very outermost tube, and the melted sulfur or the molten sulfur comes out through the middle tube or the middle pipe, where it is collected, cooled, and solidified, and it can be used directly because it is 99.5% pure. So from extraction, I will be only talking about the important words, the important points. Here we are saying sulfur can also be got from natural gas. Natural gas obtained during distillation of petroleum contains hydrogen sulfide. So when we are doing fractional distillation of petroleum to make crude oil, to get petrol and diesel out of crude oil, the natural gas that is obtained, it contains hydrogen sulfide. So this hydrogen sulfide can be removed from that natural gas. Now, a third of hydrogen sulfide burns in oxygen, and it produces water and sulfur dioxide gas. A third of the hydrogen sulfide is burnt in oxygen. It produces water and sulfur dioxide gas. So what happens? The 2/3 of the hydrogen peroxide that is left will react with sulfur dioxide, and hydrogen sulfide reduces sulfur dioxide to sulfur. As we are going to see, when we look at hydrogen sulfide, we shall see that it is a reducing agent. So it reduces hydrogen sulfide to sulfur. So this is how sulfur can be obtained from natural gas. And the natural gas, we are saying it is got from distillation of crude oil to get petrol and diesel. So that natural gas contains hydrogen sulfide. So from that hydrogen sulfide, you can burn it in oxygen to form sulfur dioxide, and we continue burning hydrogen sulfide in sulfur dioxide, we get our sulfur. But this is not very important. What is important here is the flash process, the extraction. This is the one that produces pure sulfur. This one, everyone must know by the end of today. Take note of that. Let's go to physical properties of sulfur. Physical properties of sulfur. From today and onwards, I think maybe we even knew before, sulfur is yellow in color. Sulfur is yellow in color, and it is a solid at room temperature. That's why in the extraction, we were adding superheated water. In the extraction, we were adding superheated water and hot compressed air to melt, the sulfur. I think this is where we are. Yes, we are adding superheated water to melt the sulfur such that it comes out as a liquid. So at room temperature, it is a solid. Sulfur is a typical non-metal. There is no question about it. We know that all elements which have more than 4 electrons in the outermost shell, they are non-metals. So sulfur is a non-metal. Sulfur is insoluble in water. sulfur does not dissolve in water. Please, you people take note of that. So whenever we have sulfur in water, it will always appear as a yellow precipitate because sulfur does not dissolve in water. But it is soluble in organic solvents like methylbenzene and carbon disulfide. For us, this one, we are not very much concerned with it. We shall look at this in A level, since you promised me that all of you are going to be students of chemistry in A level. We shall look at this in A level. But in our O level now, let's know that sulfur is not soluble in water. It does not dissolve in water. So properties, it is a yellow solid, it is a non-metal, and it does not dissolve in water. Let me now take you to allotropes of sulfur. What is allotrope? Allotrope, you remember, it is the existence of an element. It is the existence of an element in more than one form, but without change in physical state. So, like carbon, I think you remember, and sometimes we ask you, apart from carbon, which other element shows allotrope or exhibits allotrope? Which other element is allotropic? My friends, from today, the answer is sulfur. Sulfur is an allotropic element. And the allotropes of sulfur are the major or the main allotropes of sulfur are rhombic sulfur. Take note of the spelling, rhombic sulfur and monoclinic sulfur. These are the two allotropes of sulfur, rhombic sulfur and monoclinic sulfur. I'm going to say something very important that you must never forget. How do you differentiate rhombic sulfur from monoclinic sulfur? Rhombic sulfur, it is stable at a temperature below 96 degrees centigrade. So the only allotrope of sulfur that exists below 96 degrees centigrade is rhombic sulfur. You must never forget this. Rhombic sulfur exists at a temperature below 96 degrees centigrade. Now, from 96, it means monoclinic sulfur. For it exists above 96. So monoclinic sulfur is stable above 96 degrees centigrade. So what does that mean? 96 degrees centigrade is the transition temperature. From 96 going up, the allotrope of sulfur changes. If you have been having rhombic sulfur, after 96 degrees centigrade going up, it changes to monoclinic what? Sulfur. I hope that point is noted. Rhombic sulfur, you should be having a revision book there, noting the important points, because remember, I'm going to give you assignment here. But since you have the notes, you will dig out the answers because you have the notes there. I sent the notes yesterday. You may find there are those who have not even looked at the notes. So I'm saying rhombic sulfur exists below 96 degrees, then monoclinic sulfur exists above 96 degrees centigrade. What else do you need to know? Monoclinic sulfur. You know, like we were saying about carbon, allotropes of carbon, we said graphite is, the structure of graphite is hexagonal, then the structure of diamond is tetrahedral. So for rhombic sulfur, the structure is octahedral. It is an octahedral structure, and this is its structure, which you will draw carefully in your book. This is the structure of rhombic sulfur. So it has an octahedral structure. So if I were to ask the differences, number one, rhombic sulfur has an octahedral crystal structure. This is it here. It is drawn here. Then it also exists below 96 degrees centigrade. For monoclinic sulfur, its structure is needle-like. If you know a needle, that's how the structure of monoclinic sulfur looks like, and it is here. So you draw the structures in your book. You can also get them from the textbook. So monoclinic sulfur is needle-like shaped. It is needle-like shaped, and it is a pale yellow. So for monoclinic sulfur, it is pale yellow. Monoclinic sulfur is pale yellow. Then rhombic sulfur is bright yellow. Rhombic sulfur is bright yellow. Then monoclinic sulfur is pale yellow. So take note of that. It melts. Its melting point for rhombic sulfur is 114, but the melting point for monoclinic sulfur is 119. But these are not important. What is important is the structure, octahedral for rhombic sulfur, and the temperature. That rhombic sulfur is stable below 96 degrees centigrade. You see, I have to take a lot of time such that you understand that. Transition temperature is a temperature at which I told you the transition temperature is 96 degrees centigrade. So transition temperature is a temperature at which rhombic sulfur changes to monoclinic sulfur and vice versa. So above 96, monoclinic sulfur changes to, no, above 96, rhombic sulfur changes to monoclinic sulfur. That one I've been explaining it. I hope you have taken note of it. Other forms of sulfur, we have amorphous sulfur, and amorphous sulfur is the other one I told you, which is got from natural gas, which is got from hydrogen sulfide. So that one is rhombic, that one is amorphous sulfur, but not common. So you don't need to know everything about it. Just know that it is another form of sulfur. But the most important ones, are the crystalline forms of sulfur. The crystalline forms of sulfur, which we have said, monoclinic sulfur and rhombic what? Monoclinic sulfur and rhombic sulfur. Sorry about that, but let's move on. Let's continue. So I was telling you that the most important parts of sulfur are allotropes of sulfur are monoclinic sulfur and rhombic sulfur. Action of heat on sulfur. You know, when sulfur is burnt in oxygen, it burns with a pale blue flame. It burns with a pale blue flame, and it forms sulfur dioxide gas. So I will take you directly here. If a piece of burning sulfur is lowered in a gas jar containing oxygen, it continues to burn with a blue flame, forming white fumes of a choking smell. So the choking smell is sulfur dioxide. And usually when oxygen is not controlled, it goes on and forms sulfur trioxide. But this is the equation. So when we ask for the equation of sulfur burning in oxygen, we only want this one. What do you need to know about sulfur burning in oxygen? It burns with a pale blue flame, please. Sulfur burns with a pale blue flame and it forms white fumes, and this is the equation. So when sulfur burns in oxygen, it forms sulfur dioxide gas. Now, if sulfur is burnt in iron, is heated with iron, then it forms iron 2 sulfide. You know the valence of iron 2 is 2 and the valence of sulfur is also 2, so it forms iron 2 sulfide. And iron 2 sulfide is a black solid. Iron 2 sulfide is a black solid, so this is it here. A black solid is formed when sulfur is heated with iron. So this is heating sulfur with metals. It burns, or no, heating sulfur with metals. It can be heated with zinc, it forms zinc sulfide. It can be heated with copper, it forms, this is copper 1 sulfide. It can be heated with carbon, it forms carbon disulfide. Now, let me show you the most important reaction. Even last year we asked this reaction in UNEB. It was there. Reaction of sulfur with acids. Dilute acids do not react with sulfur. What reacts with sulfur are concentrated acids. These two equations last year in UNEB, we asked them. Take note of them. Hot concentrated sulfuric acid oxidizes sulfur to sulfur dioxide, and the sulfuric acid itself is also reduced to sulfur. So when you have sulfur and you heat it, you react it with concentrated sulfuric acid. The condition is sulfuric acid must be concentrated. The products are sulfur dioxide gas plus water. Then, when concentrated sulfuric acid is reacted with concentrated nitric acid. Concentrated nitric acid with sulfur, concentrated nitric acid, it oxidizes sulfur to sulfuric acid, nitrogen dioxide gas plus water. But we are saying the condition is this acid must be concentrated. Please, please, please. These acids must be concentrated and what? That is the condition. Uses of sulfur. Now I will begin with this one. You see, the sulfur that is obtained from extraction is not very hard. It is not very hard. We are saying we just solidify it, but it was melted at first. So what do we do to that sulfur that is not hard? We heat that sulfur with rubber. That sulfur, when heated with rubber, it forms what we call vulcanized rubber. So vulcanization, the process of vulcanization is the process of heating sulfur with rubber. And that rubber, when heated with sulfur, becomes very hard. It is this one that is used to make car tires, to make soles for shoes, because it is very hard. And how do we make it hard, that rubber? By heating it with sulfur. So vulcanization is the process of heating sulfur with rubber. And that rubber becomes very hard. So one use of sulfur, it is used in vulcanization of rubber or making rubber hard. And you can only achieve that by making rubber hard by only heating it with sulfur. It is used in making matches. Here I mean matchsticks and gunpowder and fireworks. You know, when you burn a matchstick, it also explodes. Yes? It is used in manufacture of sulfuric acid. It is used as a fungicide in medicine. It is used in production of calcium hydrogen sulfide. It is used in manufacture of various compounds like carbon disulfide. But the most important uses are here, used in making matchsticks, vulcanization of rubber, and manufacture of medicine. Most medicines are made with sulfur. So these first four are very, very important. We are going to stop here for today. I will allow you to go through the notes. Those who are copying, you copy up to here. Then next time we begin with compounds of sulfur. This has been an introduction. So let us stop here. You go through. I'm going